And the number e, base e, exponential function e to the x. Where does e come from? You see this more in calculus than you actually see it here. It says as x gets very, very large, you're looking at 1 plus 1 over x to the x becomes e. And that right now it doesn't really have any meaning to you. But essentially that's where e comes from. But they wanted you to know that where it comes from. It's not magic. It is magical in a sense. Base E is what most of you are going to be working with, whether you're in the sciences. I guess chemistry you would be working to different bases, more than you would say in physics, or whether in some of the biology, or even in business. You're dealing with most of the time in E. When I take a look at the business calculus, when we hit this stuff, we deal primarily with E. And E, of course, is on your calculator. You're going to need your a calculator. I normally require mine for my class, but Freddie said he didn't use it very much. I use mine all the time, so my feeling is I need my calculator. You probably need yours too. So E is above the ln key, which is natural log, which you've hopefully seen. So it would be second E to the, and what did I just get? S. Not alpha, second, natural log. Going to give me my E. And then it's going to be, they said, negative 1.4, so negative 1.4. Now, I have it in classic mode. Some of you have it in math print. Math print's fine, but I screw up all the time because I can't really see this when it's projecting up there. So at which point I tend, if I'm typing something out, I get things in the wrong place. And then, of course, enter, and it is, and they say to 6 decimal places. So that becomes a big whoop. So 2, 4, 6, I'm going to have to round up. So this is approximately 0.246597. Woohoo! Now E is approximately 2.7. Usually when you're graphing, you can round it to 2.7. That's close enough. If you wanted to do kind of estimating, you could take it to 3, but 3 is a little bit too big, which means your numbers will be a little bit too big. But you could do it with a 3 if you needed to, but 2.7 it would be good enough. So that when I look at the basic function, if I wanted to graph e to the x minus 1 plus 4, the basic function, e is just a number. It's a base. It's like 3 to the x. This is 2.7 to the x. If all else fails, use 2.7 as your estimate, depending upon what calculator you have. So it's just a number, so it works just the same as anything else. So y is equal to e to the x is your basic. The domain is all real numbers, no denominator, no radical. He has an HA at y equals 0. That's what I need to know in order to do the transformation. The exponent, this is an x minus 1. X minus 1, that's a plus 1, which means it is what? Right 1. And then there's a plus 4 hanging off the end, and that plus 4 says it is up 4, right? So draw my t-bar chart, and then x, and then e to the x. So negative 1, 0, 1, HA at 0. That needs to be included. E to the negative 1 Now, if you've got a grapher, and some of you may or may not know this, I've got an E already in there. If I do second enter, that brings back what I just did, and I can edit it. Graphers have what's called a buffer, and if I do second enter, second enter, second enter, second enter, you get a whole bunch of stuff that you've done, that I've done previously, and eventually it will cycle back. See, there's quite a bit in there. Some of your newer ones actually allow you to scroll up. So there we are. We're back to where I started. And then I just can go in there and edit this, and I want -1. And approximately 0.4. That's good enough. E to the 0 is 1. E to the 1 is E. That's 2.7. Do enough of these, then you don't have to do it on your calculator, at least the big 3 anymore. I want to do a right 1, so I'm going to add 1 to the x's, so this becomes x plus 1. And so that's 0, 1, and 2, and HA. And I'm going to go up 4, which means I'm going to take y and add 4 to it. This would be 4.4, 5, and 6.7, and 4. And that's my new. First thing that I want to put in is my HA, and my HA is 1, 2, 3, 4, y equals 4. And now I get my bend. If x equals 0, y equals 4.4. If x equals 0, y equals 1, 2, 3, 4, and almost 4.5. If x equals 1, y equals 5. Oh, come on, Peterson. Okay, yeah, already. If x equals 0, y equals 4.4. 4.4. Where are you guys when I need you? If x equals 1, y equals 5. If x equals 2, y equals 6.7. So 4, 5, 6.7. There's your bend. And up it goes. I was looking at that dang line, and almost, to me, it looked like it interpreted it as the x-axis, but it wasn't the x-axis, which is what got me into trouble.